Up and running. Okay, so here are the problems that you gave me to kind of look at, and I think we meet later today, so happy to see if you want more practice with these after you watch this. I got time this weekend to make whatever. So let's do a couple of problems that we did the last time. That's how I generally approach my class. It's just one or two every day until I see you making progress. So let's talk about f of g of a. Open circle here, f of g of a, which means you do g of a first, and then whatever you get as a result, you plug it into the f function, or you perform that calculation on what you get. So I prefer this notation. And so if we were to do g of a, well, g of a is already written. It's a squared plus 2, which means if I put a number in for a, like 5, then I get 25 plus 2. This is the number 27, but notice I put it in parentheses because it's got two parts. And now I'm going to put that into the f function. What's the f function ask me to do? It takes whatever the input is, multiplies it times 5 plus 3. This is the new input. So I'm going to multiply it by 5 plus 3. And that's your answer. I suppose you could do it out. 5a squared plus 13. A little simpler way of writing it. So that's what we practiced last night. Hopefully you saw that. Done. We also looked at finding inverses. I pick a number 4 here because 4 minus 3 is 1. And so 22 over 1 is 22. So down here, we want to get a function that takes a 22 and brings us back to 4. It's like walking into the woods. You want to get back, you got to retrace your steps. So the evaluation is hard to easy. So solving is easy to hard, right, in terms of operations. So you multiply, this is what we did last night, 5x plus 2. Multiply this out, yx minus 3y equals 5x plus 2. Oh, I didn't need, waking up here. Changing the x's and the y, so forgive me. So x equals 5y plus 2 over y minus 3. Now multiply by y minus 3 and you get, I'm going to do it the two parts, saving one line of work because I'm running out of space. Can you see? You won't be able to. Now you can. Okay, so again, 4 got you 22. We wanted 22 to get us a 4. So x times y is xy. X times minus 3 is minus 3x equals 5y plus 2. Got to get y equals. Well, the only way we can get y equals is get our y's together. So I think I'll bring the y to this side. It reads better. So xy minus 5y equals 3x plus 2. Then we factor a y out. Y times x minus 5 equals 3x plus 2. And then hopefully you can see what to do next. We're going to take 3x plus 2 and divide it by that quantity to isolate y. Then we're going to drop a 22 in. 66 plus 2 is 68. 68, 22 minus 5 is 27. And I did something stupid. So let's find out what that was. 22 minus 5 is 17. That's what was stupid. Right at the end there, and that is 4. 4 times 17, 68. So we can check that and move on. And that's why you check it with a number just to, well, I had it right, but that's a mistake. But oftentimes you might make a mistake doing the problem. You'll catch it. So what's new? Oh, we have one more problem from last night. So I dropped a 6 into x. 6 minus 4 is 2. 3 squared is 9 times 5 is 45 plus 3 is 48. If we don't get back to a 6, we don't get x equals 6, we got a problem. So we subtract 3, 45. Boom, we divide by 5. 9, boom. Now we're at the 3 to the x minus 4. And do you remember what to do with that? I mean, we know it's a 2, 3 squared is 9, but that's not the issue. The issue is what happens if this was 99 or 91 or something else. So right now it's 9. And I hope you recognize that exponents can be expressed as logarithms. There's your 2. 3 to the 2 is 9. Remember, that's a command. It's asking, what do you put on top of 3 to get a 9? That's a 2. And so add 4 to 2, then we get back to 6. So that's just a quick repetition of what you did yesterday. And repetition is your friend. I make my students do that once every day for the whole semester. I can't do it once every day, but pretty close to that. It only took what, 30 seconds? So maybe, yeah, every day. All right, so we got a division problem. What's the inverse of division? Multiplication. All right, so if you had a multiplication of 5 times 4 divided by 5, I hope you would say that's the number 4, no matter how you did it. Whether you did 5 into 5, which is 1 times 4 is 4, 5 times 4 is 20 divided by 5 is 4, 4/5 times 5. 4/5 times 5 is 4. Now, one of those methods was the easiest, and it was 5 into 5, and just seeing the number 4. So that's what we're after. We're after that. How do we get there? Well, we show products. I mean, we do have products, but these can be broken down further. So what's x squared minus 6x plus 9? Well, that's x squared. I'm sorry, that's x minus 3 squared. You might have seen it as x minus 3 times x minus 3. So I'll leave it like that. What's the rule for factoring that parentheses? The first rule of writing products, factoring means to write as a product. That's a subtraction. That's a difference of two terms. We're going to write it as a product. And how do we do that? We take out what's common. What's common is times x minus 9. Now we're going to do the same thing in the denominator. What's common in that? Oh, 4 is common. So I think I want a positive x, so I'll take a minus 4 out. Minus 4 times, and I'm going to rewrite it in the other order. Minus 4 times x gets me that term. Minus 4 times minus 3 gets me 12. We can already see a simplification. What's the first rule of factoring? Take out what's common, which is always the smaller exponent. So this is times, I'll put a dot there. Don't really need to, but I did. X squared times what? X minus 3. Oh, we got another one. Boy, that's gone too. So what's left here? In the denominator, minus 4x squared. In the numerator, x times x minus 9, which nothing's going to, well, yes, we do have a cancellation. Do you see it? Right? I mean, what is x squared? X squared is x times x. So boom, one of them goes. And we get x minus 9 over negative 4. I hope you never leave it like that. Always switch the signs if you got a negative in the denominator, because this can be multiplied by -1, -1. It's quickest and easiest just to change the signs of everything. So minus x plus 9 over 4 is a trick of the trade. Let's see if you can see that to be true. 5 minus 2 over 3 is equal to 1. I'll change the signs of everything. Minus 5 plus 2 over -3 is still 1. -3 divided by -3, so you can see that you can do that. All right. So that one's done. All right, I should have done this one first. You put it in that order, so I did it in the order I saw it on the paper. This is obviously easier than this one. So you always want to build up to our difficult problems. So what do we have here? We got a factoring. What undoes division? Multiplication. Well, that's not expressed as a product. Can I express it as a product? Certainly. What's the first rule of writing products? Writing sums as multiplication. Take out what's common. What's common? 4 times x plus 1. Oh, bingo. Those are going to go right away. You got x minus 2. There's your 4 over x minus 2. All right. Same thing on the next problem. We'll do that in a second because we did do this last night. I forgot to do it. What did we do? Well, what did I do or show you? Cover up the 3 and just multiply everything by x. So that's x to the 4th. It goes up 1. It goes up 1. It goes up 1. It goes up 1. Then you've done that. Now multiply by 3, but put it in columns. It just speeds the process up by doing that. Minus 12x squared. 3 times 5x. You got to be careful. 15x. And I'm talking to you. I make careless mistakes when I'm talking. 3 times 2 is 6. And then add it up. So there you got your 1 to the 4th. You got your minus 1x cubed. You got your minus 7x squared. You got your 17x. Then you got your 6. And it's no longer a tough problem. If you're putting it, because you go off the page if you write it out differently. So that's a method of handling that. All right, so this is the other one that was on the sheet you gave me. Let's take a look at it. All right, we're solving an equation. Let's just look at something quickly. 6 over 2 is 3. 10 over 5 is 2. And that's equal to 5. Okay, so let's say I want to see this without fractions. Well, if I want to see it without fractions, then I multiply out the divisions. The 2's will cancel. 5 times 6 is 30. The 5's will cancel. 2 times 10 is 20. Nothing cancels. 2 times 5 is 10, times 5 is 50, and we can see that we have an equality. Equal sign means may be written as, so 30 plus 20 may be written as 50, certainly can. So let's apply that. What's r plus 2? It's a number. It's a number when you put something in for r. So let's get that number out here. Boom. And we're going to multiply the whole thing across. Oh, I want to see what these numbers are. So I want to factor that. I want to look at r plus 5 times r plus 2. All right, we want to get good at that, and that's another way of writing that. So I am actually going to replace this with that so that I don't have to write so much. I have the board here. Board is my friend. So r plus 5. Having trouble making an r plus 2. All right, so I've already got the r plus 2's canceling. Just with that, I also got to cancel the r plus 5 because I don't want to deal with it. So r plus 2 cancels. I get one of these statements. Everything cancels with this. So I just get the number 1. The r plus 2's cancel. So I have to multiply r plus 5 times 6. And I just got to be careful. 6 times r is 6r. 6 times 5 is 30. And I should say at this point, if r equals, it cannot equal -5, -2, or -5. So if that comes out of this, I got to say I can't use those numbers because you're not allowed to divide by 0. All right, and here's why. 6 divided by 2 is 3. How do we know? Well, the inverse exists. 3 times 2 is 6. If you thought 5 divided by 0 equals 0, then 5 would equal 0 times 0, and you got a problem. Now, I can divide something into 0. I can do 0 divided by 5. Yeah, that's 0. Why? Because 0 equals 0 times 5. That's true. Okay, so you can divide into 0, but you cannot divide by 0. Okay, so I can't use the number -5 or -2 because that would be a division by 0. All right, piece of cake here. Addition of r becomes subtraction of r. Addition of 30 becomes subtraction of 30. So your answer is -29 over 5. And this is the kind of thing that, you know, you probably should take the time to check to sharpen your skills with fractions. Not often, but when you're first learning a concept, it's very helpful to actually see the numbers work. I don't think I'll do that right now because I've done that in the past. All right, so I'm going to offload this. This is good practice for you to get ready for your final. And hopefully, you know, when I see you later today, if you need more practice than that, you let me know.